Welcome everyone to another episode of Coding Talks. Myself Vishnu Viji, and today in this episode I will be talking about the MCP servers and about the integration of MCP servers in an enterprise AWS environment. So this session is more focused on AWS and the .NET domain. Even people from other programmers from other background can also benefit from this. The agenda of today's episode is like we will start with an introduction of MCP servers that will give you a context about what MCP servers are and why are they so relevant in the context of AI application. Then we will specifically look into the MCP protocol and why Anthropic came up with that MCP protocol to standardize the LLM interactions. Then we will be looking at a higher level overview of an application that is using MCP server. We will also see what all components are there inside the MCP server, and then once we understood and get a basic idea about the MCP server, then we will look into specifics about the challenges that we found in integrating the MCP server, especially on in an enterprise context. Then the AWS provides some guidelines on how to create enterprise level MCP servers. We will look into the one of the reference architecture that AWS provides, and we will look specifically into the components that are using there. Then the once we understand that, then we will be looking into the evolving deployment patterns in MCP server with the Amazon Bedrock Agent Core. This is like an integrating the AWS specialized AI agent platform to take advantages of the agents within the Bedrock context. So Bedrock provides a managed AI environment which you can use through an API. Then we will also look into some of the popular MCP servers out there, and we will specifically look into an example of an MCP server that is provided by AWS and how that MCP server can enhance your LLM based AI applications. Then finally we wrap up with an understanding about how to develop an MCP server in using .NET. We will understand in simple terms how you could develop an application, MCP server application using .NET, so that you will get a picture about the overall view of the MCP server. So you will understand, you will get enough understanding about this so that you can develop MCP server based AI applications. So we'll start on that, and all the opinions that I expressed through this podcast are purely personal and do not represent any of my employers' view in any way. And the podcast will be available on all podcast platforms, including Spotify, Apple Music. Feel free to listen from any of the platforms as you like, and also in the AWS community platform. This will be available as an article as well. So in case if you want to go through the article, you could follow that as well. So we'll start with that one. MCP servers are actually, a buzzword out there. A few months back, here in Bangalore, I was attending different technical sessions. Whether it was an kind of starting with the AWS Summit 2025, then Community Day, and also MongoDB, or lot of is that there would be a topic about the MCP servers. So a lot of technical sections were happening, and even now at the time of this podcast, as of July 2025, I have found major cloud vendors and organizations releasing MCP server, whether it is Redis or MongoDB or Microsoft or AWS. So MCP server is getting very popular, and there are still more advancements coming over the MCP server as well. So thought I thought to put a few words about the MCP server, and that's what you are listening through this podcast. So the before listening to the podcast, I assume that you have some idea about the LLMs and the cloud architecture, and I will be explaining this in context of AWS services and .NET in specific, but you could relate it to other languages as well. So this podcast can be think of as a language agnostic one, but I will be explaining it in terms of the .NET domain and AWS in specific, but you can apply it to any languages because the core concepts that I explain here in this podcast will be applicable for all languages. And I try to avoid the technical terms as far as possible, making it a generic understanding appealing to everyone. And again, all the opinions expressed here are purely personal. We will start off with an idea about what MCP protocol is all about and how it came into existence. So back in the November 2024 time, David, who is one of the co-creators of MCP, he is from Anthropic. He was trying to integrate some form of workflow. Workflow means our business applications has a lot of workflows. So he was trying to integrate on workflow into the AI applications in a simple way. So it was a way of giving context to an application that uses an LLM. So that's how the MCP, the idea of MCP server came into, and he was trying to provide the context. So this context can be tools, it can be a raw content, and why the need for that context is like while the LLMs are great for enabling intelligence to your applications, especially the AI application, but when it comes to interacting with an external data source, or if your AI application want to initiate some action, it would be challenging that with just the help of LLMs. Theoretically, your LLMs could call an API or to parse some external data, but that's not the goal of LLMs. So LLMs are meant to be provide intelligence ability to your application. So the MCP protocol came out as a kind of a standardized way to provide the context to LLMs, so that that frees the LLMs from connecting to external data or to initiate some kind of an user actions. Actions can be anything like to create an event, or maybe it's to call an API or to send an email. So different kinds of events can be, or it can be to get some context about the application, like it can be read something from the database, or it can read something from an API. So these are kind of the need for the LLMs to perform better. So if LLM is actually involved in calling the different APIs or to initiate actions, it would be challenging for them. So a middle layer like an MCP protocol came out as a standardized way to provide the context to LLMs, so that LLMs got free from connecting to the external data. So that's exactly what the MCP server does. It provides context to the LLMs. Not just provide context to the LLMs, it can also initiate actions. So through the help of an MCP server, an LLMs can initiate an action or can understand more about an external source. So that means you can standardize these things, external resources and also in actions using an MCP server. So if we look at the higher level view of an application using the MCP server, there will be a couple of components like the basically the application that we want to use, or you can call that your intelligent AI application which uses an LLM. Then we need an MCP client that helps to connect the LLMs to the MCP server. So that lies between the LLMs and the MCP server. That's the MCP client. Then the actual MCP server itself. So the actual MCP server is where you define the MCP server, you define the action, you define the resources, and you define a context of how the user is going to interact. Like you provide a prompt, a kind of a templated prompt which can help the it acts like a mapping. So it acts like the mapping from the LLM to the external world. So if we dissect more about the MCP server in more detail, that's the actual implementation by the Anthropic. It has three main components. One is the resources. So this is specifically into the MCP server which I am explaining about. If you look deep into the MCP server, its core components are first one is resources. Resources can be considered of as a kind of a information retrieval mechanism. You can think of that in different ways, like it could be an API that reads from an external system, or it might be some form of a database interaction that reads from somewhere, or it might be some kind of an input or whatever form of input that the MCP server gets from external resources. The key point here is the resources are actually read-only mechanisms. So that's the one which provides the context to the LLMs. And then the in the MCP server there is a concept called defining actions, by which the actions are the components that can make changes to the system. So it involves initiating something like a send email, or it can initiate something like an event, or makes changes to the database or something. Those all can be considered as an action. And why defining this action is relevant in the MCP server is through which the LLMs can initiate actions as well. So if you want to send something from the LLMs or your AI application, you can simply provide a prompt like send an email, and that natural language can be easily mapped to a corresponding action in the MCP server. So LLMs automatically do that on behalf of you. So the one more key components you need to define in addition to the resources and the action is the prompt. And the prompts are the simple templated messages that can help the LLMs or agents to map the specific natural language to specific action or to retrieve information. So when the user or the someone in the application who prompts the LLMs to provide an information, it calls the resources and provide that, and same time if it wants to take some initiate actions, it will be do on behalf of MCP server, and all with the help of these templated messages that can help LLMs to identify which resource to call or which agents to which actions to initiate. So this help, so that means the a capable MCP server with the respective actions and the corresponding resources can help the LLMs to make better decisions. So all these are specified in the MCP protocol released by Anthropic back in 2024, and this specifications enabled the LLMs to create MCP servers to do much more than generate simply the text. Hope all of you are aware that previously the LLMs were basically used for generating text, whether it can be some form of and providing intelligence to your system, or it can generate content from existing contents, or it can generate new contents based on the information that you provide, and all those were the capabilities of LLMs. And with the help of the MCP server, it gets additional context, like it can get a standardized way to get more information, and in addition to that you could find a way to initiate actions as well, so that you can use natural languages to do these actions or to retrieve information. So that's why if you look currently, you can find a lot of MCP server implementations, just like you can some implementations like changing channels, recording videos, and creating music. All this, there were specific MCP servers for that. So lot of MCP servers are available, and you can search about some of the interesting MCP servers, ready-made MCP servers available out there. So once such an MCP server is available, you can create your own, or you can use an existing ready-made one. And once you have such an MCP server, the advantage is that your applications or LLMs can connect to those servers and make the LLMs more powerful. Then these are all an overview about the MCP server which we were discussing. Now some of the challenges in integrating the MCP server, challenges when it comes to integrating the MCP server in an enterprise context, is what we are going to discuss next. So up to here, the idea of the MCP server is simple to understand. But the challenge in implementing an application with an LLM to an MCP server is how these MCP servers can be authenticated, especially when it comes to an enterprise context. So in an enterprise, there is a need for a centralized mechanism to implement the authentication. The MCP server has evolved a long back from its initial inception back in the late 2024. So during its initial days, the focus was on demonstrating the usage of the MCP server with the basic key level authentication. But by mid of 2025, more specifications were added, especially related to the authentication, because in an enterprise context, when more and more cloud providers were adopting the MCP protocol and creating MCP servers, there is a need for an enterprise integration mechanism, especially the authentication mechanism. So by mid of the 2025, after its release in 2024, the Auth 2.1 specification was introduced to the MCP protocol. So that means the identities that are based on OAuth can be integrated easily with the MCP server, and those identity platforms can be used as a standardized way to authenticate the MCP server. So this authentication is important, because if your MCP application, if your client or the AI application or the LLMs wants to connect to the MCP server, especially in the context of an enterprise, it should be authenticated. Otherwise, we cannot trust to which MCP server it is actually getting connected to. So authentication is a key, and that's why the OAuth specification was introduced, and this evolved the MCP server into more integrations with the cloud platforms, and lot of MCP server implementations by different major players came out from AWS, Microsoft, and so on. Then it further evolved into more dynamic registrations, allowing clients to register to the MCP server. And the recent one, integration, authentication integration, is the resource servers, where the MCP servers act primarily as resource servers, delegating the actual user authentication and token issuance to external authorization servers like Amazon Cognito, Microsoft Entra ID, or Okta. So with the help of these resource servers, the standardized integration patterns, identity integration patterns, can be integrated with MCP server, and this closely aligns with the enterprise security architectures as well, because most of the enterprises were utilizing these existing patterns, identity patterns, like the Amazon Cognito or Microsoft Entra. So with the adoption of this in the MCP server, more stable authentication mechanisms can be implemented, and this allows more popularity of the MCP server in the context of enterprise. And nowadays the Okta is also another provider which can be integrated. So there are a lot of providers which can be integrated, but if you look into the key players out there, Amazon Cognito, Microsoft Entra, or Okta can be used as the identity provider. And now with this auth specifications and all, the AWS has released guidelines for creating enterprise level MCP server. It will be good to discuss a little bit more about that before we moving further, because AWS has released these enterprise level MCP server based on the guidelines from the well architected framework. So most of you are aware, like using the well architected framework, we could develop reliable, scalable, and secured enterprise level applications. AWS provides a set of guidelines for that, and you can find out that in the AWS documentation, especially for those of you who are not aware of that one. And this guidelines they have provided for the MCP server guidelines, I will provide the link in the description below for this podcast, and you can find more details about the guidelines they have provided to create an enterprise level MCP server. This has all the mechanisms in place, the secure mechanisms in place, and also it's scalable. So please find the link that I have attached in the notes. And this architecture provides a kind of a template for starting an MCP server. So it's a very this architecture will evolve in the upcoming days, but AWS will add more and more improvements to this architecture, but the core idea remains the same. And this architecture guidance demonstrate how you can securely run the model context protocols on the AWS cloud using the containerized architecture. And this architecture, this template helps organizations implement the industry standard auth authentication while protecting the server deployments with multiple security layers. And it is also included with the content delivery networks and web application firewall, so it offers protection. Then the details of this is available on the AWS documentation, but if you look into a higher level overview of the architecture, it starts with the user and the MCP clients. You can imagine like a user, you are sitting at the computer interacting with the MCP client. You can also think of this could be like a desktop application, like a cloud desktop or a VS Code extension, or any application that you develop that speaks the model context protocol. And your interaction goes straight to the AWS cloud. And the entering point of the AWS cloud in this architecture is via the CloudFront and the web application firewall. So your request from the MCP client first hits the Amazon CloudFront. The CloudFront is a global content delivery network, and it's a kind of a first line of defense. So security is implemented at the first stage itself, and it helps to route the traffic effectively and provides caching as well. And immediately behind the CloudFront is the AWS Web Application Firewall. So web application firewall is very important here because it inspects the incoming request that coming from you, filtering out the malicious traffic and protecting the application from common web exploits. So at the initial layer, once your MCP client tries to connect to this architecture, at the initial level itself, there will be protection from the CloudFront and the web application firewall. So please also go through the article that is available, which I provided in the show notes, so that you can get a better understanding of that. And also AWS provides a detailed documentation as well. The architecture diagram and the code base is also available on the article, so you can refer that. You can navigate that on the AWS documentation as well. So that will provide you a good context to get started. So once the request reached the CloudFront and it passed through successfully through the web application firewall, then the next level is the set of components called the application load balancer and VPC. So from the CloudFront, your request then get routed into the virtual private cloud. So this is a networking component with a segregated networking component within the AWS. And inside this VPC, the first stop for your request indicated is an application load balancer or ALB. And the ALB's or application load balancer job is to distribute the incoming application traffic across the multiple targets. Like you might have multiple MCP servers to ensure high availability and responsiveness. So there is not just on my MCP server. The functionality will be same, but actually there will be multiple MCP servers to ensure high availability. Then from there, the authentication journey begins. We discussed about the authentication as one of the crucial component that is required in enterprise application. So the authentication is implemented at this stage. Like it is implemented using the MCP auth service and Cognito. Cognito is on component service from the AWS. And now this is the area where the authentication becomes the key, and it's kind of a bit of a loop. From the ALB, that is the application load balancer, the request that needs authentication is redirected to the MCP auth service. And this MCP auth service is a very important component within the VPC. The MCP auth service, basically it's an application. We then initiate the auth flow that it initiates, and then it redirects you back to the Amazon Cognito. So Cognito is a AWS identity service. So the MCP auth service, once it identified that you are not authenticated, and that's initially it's kind of a loop actually. So once you get the request from the ALB, the MCP auth service redirect back to the Amazon Cognito. The Cognito being the AWS identity service acting as the authentication server. So the Cognito then authenticates and logins the user. Once authenticated, the Cognito issues tokens. This token, along with an authorization code, is sent back to the MCP auth service, and then the MCP auth service can then, if needed, they can interact with the backend database like a DynamoDB to retrieve some specific user-specific information about the authentication, and that way it can validate it. So once the MCP auth service has validated the tokens from the Cognito, it now has the necessary credentials to allow the MCP client access, and then the auth service will securely authorize the traffic back through the ALB. But this time the ALB routes it to the actual MCP servers. So the initial request coming from the client, ALB redirects that to the MCP auth service, and with the help of Amazon Cognito, it ensures that the user is authenticated, and then finally routes to the MCP server. So here you can see like the authentication is taking place, which helps to ensure that the your MCP server implementation is secured and it can be used in an enterprise context. Now coming to the actual MCP servers here, in this AWS provided guidelines, they will be using the AWS Fargate and the AWS Lambda. Also, there are other approaches you can also use here, but here the basic approach is like the AWS Fargate and the Lambda. Fargate is a kind of a serverless compute engine for containers. It lets you run containers without having to manage the underlying servers. It's very highly scalable and very popular for the scalable workloads as well. And similarly, AWS Lambda is another type of component for more event-driven or short-lived like MCP server function. You could use the AWS Lambda. So either one of the components can use. So in the actual MCP server implementation, you could use the AWS Fargate or AWS Lambda. And the distinction between which one to choose depends upon the AWS Fargate is actually a container, so it's actually easier to run the containers without how to manage the underlying servers. And AWS Lambda actually is suitable for event-driven based short-lived MCP server function. And then both Fargate and Lambda would host your actual MCP server code. Either one of these will code the actual MCP server codes, where you define your actual tools, resources, and prompts. Before we discussed about the core components of an MCP server as per the Anthropic protocol specification, the key components are actually the actions, the tools, then the resources, the component to pick the information, and the prompt which maps the LLM into the specific MCP server actions or resources. Then other than that, you could also find a set of other components as well in this architecture, which is provided by AWS. So these are like the kind of a security mechanisms, like the secret manager, parameter store. These are critical for enterprise application, and also CloudWatch, which is a logging service, which is also required to find out in case if any error happens in a specific stage of the MCP server implementation. You could find out that as well. And then the Amazon ECR, this is the component where your actual the container images for the Fargate. If you are using the Fargate, the container images for Fargate will be stored here. So your MCP server code would be packaged as a Docker image and pushes to here. And the Fargate uses this ECR to pull out the Docker image and spin up that as a container platform. Then these are there are minor other components like even though it's minor, it's actually an important component like CloudWatch, parameter store, and all. But actually the core components are we discussed here. And we will also discuss about one of the evolving deployment platforms with the MCP servers, that is with the Amazon Bedrock Agent Core. So the guidelines which we just discussed. It provides a robust general purpose architecture for deploying MCP server on AWS. But there is another one service which is an service managed service by AWS, which provides a kind of a managed AI service through API. So that's called the Bedrock service. You can find out more about this service in the AWS documentation. Amazon Bedrock has introduced several services designed to further streamline the deployment and operations of the AI agents and their associated tools, including the MCP server. So there are a lot of things to explain about the Amazon Bedrock Agent Core, and we could discuss that in a separate episode. But on a basic level, Amazon Bedrock Agent Core is a comprehensive platform that simplifies the process of building, deploying, and managing production-ready AI agents. So the key components which are relevant to our MCP server discussion in Bedrock is, Bedrock is also a managed service which provides a lot of foundation model. You can call a standardized API to connect with the underlying LLMs and get the output. But in addition to that, when it comes to MCP servers, some of the key components that are related to Bedrock is the agent core runtime. So this agent core runtime provides a secure serverless environment built for hosting your AI agents and critically your custom MCP server logic. Instead of directly managing Fargate containers or Lambda functions for your MCP server, you could containerize your MCP server application and deploy it to the agent core runtime. This runtime offers benefits like a complete session isolation, support for long running workloads, and fast cold starts. So cold start is a condition where it would require some time for your Lambda to spin up, especially the initial request. So this one can help to solve that. And next important component when we think about the Amazon Bedrock Agent Core is the Agent Core Gateway. This component acts as an integration layer, transforming existing APIs such as the HTTP endpoint of your MCP server into agent-compatible tools. It explicitly supports the model context protocol, making it easier for Bedrock agents to discover and invoke the capabilities exposed by the MCP servers. Then Agent Core is also integrated with the identity, memory, and observability. So these components further enhance the enterprise readiness of your AI solutions, providing built-in management like the existing identity providers like Cognito, conversation memory, and comprehensive monitoring capabilities. So while we discussed about the architecture principles of the security layers previously in the AWS guided guidelines for the MCP servers, we discussed about CloudFront, Web Application Firewall, ALB, and also identity providers like the Amazon Cognito. Agent Core offers a more integrated and specialized environment for hosting and managing your MCP servers. So some of these components which we were discussed already were inbuilt within the Agent Core runtime. So you could focus more on the business logic and less on the underlying infrastructure orchestration. So if you are using the Amazon Bedrock Agent Core, it will be more easier for you to develop AI based applications with the MCP server. Now So far we were discussing about the AWS guidelines and the more advanced integration using the Bedrock agent core. Now we will be discussing about some of the generic aspects of MCP server. So we started with the evolution of MCP server. We understood the relevance of that, and when we dived deep into the AWS architecture using the generic guidelines as well as on the enhanced approach using the Bedrock agent core. Now we are coming back to the some of the generic concepts of MCP server again to lighten the talk a little bit. So as of the adoption of the once the adoption of the MCP server has gained popularity, there are a lot of MCP servers out there, and it is easier to integrate your existing applications. So you could develop your own MCP server for your enterprise, or maybe you could use an existing MCP server. There are a couple of things you need to be aware of, like what kind of MCP server you want to connect, whether it is a secured MCP server or not. You have to make a decision on that, and also make sure try to avoid confusing the LLMs, because your LLMs will be interacting with the MCP servers. So if the MCP servers provides a similar nature of actions or resources, then that will, or if it defines a similar kind of a prompt, then it will confuse the LLMs to identify what decision to make. LLMs can be think of as like a brain, and the MCP server can be think of like an kind of a context provider or an action initiator. So it has to be defined uniquely so that LLMs won't get confused of that. Now you could develop your own a custom MCP server, or you could find out a lot of MCP servers out there. There are a lot of vendors based MCP servers available out there. If you think about a few of them, you could see like the Redis provides one, Microsoft provides one, and MongoDB also provides a lot of. These are all a few examples that I am providing, but actually there will be more implementations as well. You could find a lot of implementations out there. That much popularity this MCP servers will have. But we will examine on specific MCP server in detail so that you can easily understand the importance of MCP server much easier. So that is about a ready-made MCP server which is available from AWS. AWS, which is provided by actually AWS Labs. So if you are interested more about the different MCP servers, ready-made MCP servers provided by the AWS Labs, you could search about that in there, and it's also there in the AWS documentation. But these ready-made implementations provided by the AWS serves different purpose. So if you take one example of the AWS MCP server, that is the AWS documentation MCP server, we could discuss a little bit more about this AWS MCP server. The reason for that is once you understand this AWS documentation MCP server, you could similar, like a kind of a similar pattern, you can use other MCP servers as well, especially the ready-made MCP server. So let's look into what is this AWS documentation all about. Imagine that you are building an AI assistant. So this AI assistant is specifically for AWS services. You want your AI assistant to answer questions about AWS services, so that it helps a developer or those interested in AWS development to find out the right API or to explain some feature about some of the services of AWS like the EC2 or S3. Normally, uh, your LLMs, if that LLM want to answer these specific questions about EC2 or S3, you need to train that LLMs with a massive data set. And the problem with that approach is sometimes that might get outdated. So you have to build a custom retrieval system to search AWS documentation and feed it to the LLM. So LLMs need to be updated frequently with the data set. So the MCP server or the AWS documentation MCP server specifically in this context will provide more information which the LLMs can use. So if you look into the working behind actually the MCP server, the AWS documentation MCP server exposes the AWS documentation as a resource, and this MCP server is specifically for the information retrieval. It translates your natural language queries from an LLM into the structured request that can then search, filter, and retrieve specific sections or pieces of information from the AWS documentation. So the core benefit is like instead of LLM hallucinating or needed to be fine-tuned for every AWS document update, it can real-time query the official documentation MCP server. Example, it could query the MCP server like how do an IAS assistant could receive a query like how do I set up a VPC endpoint for S3. The MCP client or your AI application could send this to the AWS MCP documentation server, which would then look up into the relevant sections in the AWS documentation and then return the exact answer to the LLMs. So these are some of the benefits that it serves, and also it helps to enhance the AI powered application system, and more importantly it can help to help the LLMs to stay current with the help of the MCP server, and LLMs can focus on the intelligence capability of the application. And with that, we could come to the final part of this episode where we will be discussing about how to create a MCP server in .NET. So given all this, we have discussed about the AWS pattern, AWS guidelines, enhanced patterns and all. But if you are interested to create a MCP server by your own, this is not specifically to cloud platform or anything. This is your own MCP server if you want to develop. That will be the one which we will be hosting inside that AWS Lambda or the Fargate container as we discussed earlier. So if you want to develop your own MCP server, the core logic behind the MCP server, the core components will be like the resource, action, and the templated prompt. So how to start with that one is like you will be starting this is in the context of an .NET Core application I am explaining. So you'll be starting with a basic web application. You could simply create a brand new ASP.NET Core web application. This will be the framework for our MCP server, which this framework will be, you will be hosting this application, you will be hosting inside a container like the Fargate or the AWS Lambda. In a case of AWS Lambda provides its own template, so you could write the handler within that. So that's and we are not going to discuss that part. We will be discussing on the the .NET core application, how to create a MCP server, and basic idea remains the same for other type of application as well. And first initially create the ASP.NET Core Web application. Then the way by which we will be adding the MCP here is like we will be adding through the NuGet packages. So that's the way by which we will be adding the right libraries to the your .NET application so that it can work like an MCP protocol. So you have to add two specific packages here. One is called the model context protocol, that is the core brain, and the another one is the model context protocol.asp.NET Core, which helps to speak the HTTP based MCP that is specifically for the web application. So this is a pre-release package as of right now. So but still you could use that. Then you have to plug in the MCP server through the program.cs file in the .NET application. This is the area where we tell our application that you are not just a web application anymore, you are also an MCP server. So we will configure it to listen to the MCP request. So in the program.cs file, you could add a couple of lines. You should specify to how to become it like a MCP server, and finally you map the MCP middleware to a specific path like a /MCP or something. So this is the end URL where your MCP clients will talk to your server. So that means from your application the request will go through the LLMs and then to the MCP clients, and it will connect to the MCP server. So the core capabilities of your MCP server, that is your AI capabilities, will be defining inside the actual classes, C# classes and methods. So if you want to expose a method that you define inside the C# class as an MCP tool, you will be marking it with an attribute called the MCP server tool attribute. So this attribute helps the underlying NuGet package based MCP server to identify that this is a tool. And also you could add a description attribute to explain to the AI what this tool does and what are the parameters are. This is important for the AI to understand how to use your tool. And then once this is defined, then the client will be connecting to this application using an HTTP endpoint, and that's how it actually connects to the application. There are more things to understand about configuring an MCP, but that's out of scope of this podcast. You can learn about that through the with the help of some AI tools like Copilot or Gemini or Amazon Q or whatever that you prefer. So you could give a prompt on how to create an MCP server there, and equivalent for other application as well like Java. So with that we could wind up this episode on the MCP server. We start with an understanding about the MCP server. Then we looked into AWS specific guidelines, and then we looked into advanced implementation using the Bedrock, and then we also saw how to use the existing the MCP servers like a ready-made servers, and we dived more deep into one specific example of the AWS documentation server and how it helps. And finally we wrapped up our session with an understanding about how to create a MCP server using a .NET application by integrating the corresponding NuGet packages and attributing your methods with the corresponding MCP server defined methods. And so with that we can wind up this episode, and thanks once again for listening to this podcast, and we'll come up with another episode soon. Thank you.